Hello everyone. It is a privilege to speak with you today on this important topic, metals beyond tomorrow. As we look to the future, metals remain indispensable for modern life, from infrastructure and transportation to green energy solutions. Yet, the challenges of finite resources, rising demand, and environmental concerns need innovative solutions. This presentation is based on a recent paper we wrote in Elsevier's Materials Today journal. The paper is referenced in this slide. This paper is open source so that it is easy for you to find it if you want to review the background research. We want to examine how we can balance supply, demand, sustainability, substitution, and innovation to secure a sustainable future. After this presentation, please feel free to leave your comments or questions below so that we have an opportunity to respond to your thoughts.
Metals form the backbone of modern society. They are indispensable across critical sectors such as housing, energy, healthcare, and transportation. Their importance has only grown with the advent of green technologies, where metals like nickel, rare earth elements, and lithium power electric vehicles, wind turbines, and solar panels. However, this growing demand has introduced a complex challenge. Metals like cobalt and tellurium, critical for green technologies, have limited reserves, making their availability uncertain. As we forge ahead, we must ask ourselves, how can we meet the growing global demand while ensuring sustainability? This question sets the stage for today's discussion.
The metals industry is at a crossroads, facing simultaneous challenges and opportunities. On one hand, we have finite reserves, declining ore grades, and the pressing need to align with international climate goals. On the other hand, these challenges push us toward innovation, collaboration, and more sustainable practices. By focusing on smarter resource utilization, advanced recycling, and greener production technologies, we can turn these challenges into opportunities to modernize the industry while addressing environmental concerns. The cost and scarcity of metals reveal the immense disparity in resource availability. Some metals, such as steel and aluminum, are abundant and affordable, costing under $1 per pound. However, metals critical to green technologies, such as platinum and iridium, cost thousands of times more, reflecting their scarcity in the complexity of extraction. This disparity underscores the need for sustainable practices, substitutions, and technological innovations to ensure that these resources remain accessible for future generations. Let's look at the lifetimes of our current metal reserves. Metals like iron and aluminum have lifetimes exceeding 50 years, offering some breathing room. However, critical metals like cobalt and zinc are at risk of depletion within a few decades. The increasing demand from green technologies shortens these timelines further. This is why the U.S. Geological Survey continuously updates its critical minerals list, recently adding nickel and zinc to address their rising importance. The key takeaway is that without enhanced recycling and sustainable mining practices, we could face severe supply bottlenecks in the near future. As we move into the mid-century, metals like copper, lead, and zinc are projected to surpass their critical supply limits. This overuse poses significant supply chain risks, especially as demand for green technologies grows exponentially. The solution lies in developing viable alternatives, increasing recycling rates, and investing in mining technologies that can extract metals more efficiently and with less environmental impact. This figure illustrates the interconnected nature of host and byproduct metals. For instance, gallium and tellurium are entirely reliant on the production of host metals like aluminum and zinc. This dependency introduces supply chain vulnerabilities, particularly as demand for green technologies rises. Enhancing recovery rates for byproduct metals and developing independent extraction technologies are essential steps to reduce these risks. The metals industry is a major contributor to greenhouse gas emissions, with steel production alone accounting for a significant portion. While energy efficiency in steel production has improved over the years, achieving net zero emissions remains a challenge. Innovative processes like top gas recycling and Husarna iron making offer promising pathways to reduce emissions and increase energy efficiency. Scaling these technologies, however, will require substantial investment and international cooperation. Transitioning to greener technologies is no longer optional, it's a necessity. However, the shift is fraught with challenges, from high initial costs to technological limitations. Processes like hydrogen-based steelmaking and advanced recycling technologies hold the potential to revolutionize the industry. Yet, their widespread adoption depends on scaling, capital investment, and global policy alignment. Recycling and substitution are key pillars of a sustainable metals industry. Efficient recycling of critical metals, particularly from electric vehicle batteries, can help sustain reserves and reduce greenhouse gas emissions. Additionally, exploring alternatives like thermal energy storage systems made of concrete can reduce dependency on scarce metals. Such innovations not only lower environmental impact but also provide scalable solutions for future needs. Innovations in metallurgy are transforming the industry. Nanostructured steels, for example, offer unparalleled strength and resilience, while 3D printed components like aircraft heat exchangers reduce material use and increase efficiency. Shape memory alloys and high-entropy alloys further highlight the potential to replace or supplement traditional metals, reducing our dependence on scarce resources. Collaboration between policymakers and industry leaders is essential to ensure the metals industry transitions to a sustainable future. Policies that incentivize green technologies and support recycling initiatives can drive change. Equally important is engaging younger generations, particularly Gen Z, to advocate for eco-friendly policies and foster international collaborations. The key takeaway is clear: metals are indispensable, but their production is environmentally taxing. Advanced technologies and innovative solutions like benitic steels and efficient recycling offer practical pathways to address these challenges. However, scaling these solutions requires time, investment, and the collective effort of stakeholders across industries and governments. To meet the challenges of scarcity and rising demand, the metals industry must embrace a multifaceted approach. What we do here will be important for the industry and our environment. Improved recycling practices, material substitution, and innovative manufacturing processes like additive manufacturing are crucial. By combining these strategies, we can create a sustainable future for the metals industry while meeting the needs of a growing global population. Please take a moment to let us know what you think about this issue.